तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Now, let us look at a little more complexity in it. Supposing I have n rigid bodies in a system, I am only talking about planar rigid bodies here. Okay. I know that each one of them will have 3 degrees of freedom. I have n rigid bodies which are independent of each other. This is a very important statement. They have to be independent of each other, means that I will have 3 n degrees of freedom that this system of rigid bodies have. So, this system of rigid bodies which has n rigid bodies in the system has 3 n degrees of freedom in it. Okay. So far it is clear, there is no problem. Okay. Please remember, if I have to define degrees of freedom here, I have to introduce what is called a fixed frame. In order to illustrate that, let us say I have these 2 rigid bodies. Okay. Now, let us say these 2 rigid bodies are moving in such a way that one rigid body does not see the other body moving, but yet they are moving with respect to some other frame. So, if you look at it more carefully, we need to fix a particular frame with which we talk about all these things, okay, and that particular frame is the Galilean frame of reference. Okay. And for now we will just take it as a fixed frame that I define. Okay. So, if I have 2 rigid bodies, I have to introduce the notion of a particular frame with respect to which I will be talking about the motion of the rigid body. Okay. So, this is x, this is y. Okay. So, I can have a rigid body over also be with respect to fixed frame of reference. Okay. So in other words, unless I say that these are completely independent bodies, okay, if I have some connectedness that I define, the number of values that I have to use to define the motion will come down. Okay. In a sense, that way we have maximum of 9 quantities that we have to use in order to define the motion of this system. Okay. Now let us just look at some examples here. Cut. Okay. So in order to show the connectedness, let me call them as constraints. Okay. Some of the general constraints could be, supposing I have a rigid body like this, I could probably have some kind of connection like this. Okay. Whenever I hash like this, it means that I am fixing it fixed frame of reference. Okay. So let me just think of it like this. Then I know that about this particular point this B can rotate, and about this particular point again let me call this as O, about this particular point again this A can rotate independent of B. Okay. So I have 1 degree of freedom possible for the B rigid body to move or rotate, and for A rigid body to rotate either this way or this way independently. So I have one independent rotation of B, one independent rotation of A possible. Okay. Mind you, I have fixed this particular point O of both the bodies to the fixed frame of reference. Okay. Or in other words, if I release this particular point with respect to the fixed frame of reference, I can move this point around. Okay. And this point has 2 degrees of freedom possible. It can move in x and y directions in a particular way. Okay. And therefore there are 2 degrees of freedom possible that I can move this O with if I remove the constraint over here, and therefore in total I am going to call this as 3 and 4 and I have 4 degrees of freedom in total that this system of rigid bodies A and B will have. Okay. One other way of understanding is this: body A can go through 3 degrees of freedom independently, B can go through 3 degrees of freedom independently. If this constraint were not there, what does this constraint do? Supposing I fix this body A to the fixed frame of reference, A and B are connected at point O1, pinned at O1, B and C are pinned at O2. Okay. I am just defining a fixed frame of reference. Okay. Now the question is, how many degrees of freedom does this system have? Okay. If we look at the simplest way of looking at it, we have A as 3 degrees of freedom, B has 3 degrees of freedom, C has 3 degrees of freedom, and a total of 9 degrees of freedom if the constraints O1 and O2 are not present, or in other words there is no pinning occurred here. This pinning is going to restrain the motion between A and B, okay, in both x and y directions, which means I would have lost 2 degrees of freedom pertaining to A and B. Okay. In a similar way, with O2 we would have lost 2 degrees of freedom, or in other words you do not 1 degree of freedom. Now I will fix A as well as B and look at C and ask the question whether there will be movement at all. The answer is yes, because this is a pin and the body C can move independent of A and B, or in other words this have an additional degree of freedom to move. If I add the total, I will have 5 degrees of freedom possible. Okay. The earlier method you have to take caution in using, alright. The second method is what I would suggest, is the best method to find out what are the degrees of freedom that you can find, alright. Let us look at some more examples. Let us look at this example, okay, and then let Okay, let me just mind you, there is a slot on this body A and the two are connected through a small pin that can slide along this slot, okay. And I asked the question, how many degrees of freedom can it have? So the first way I can start with is I can say, okay, I have 3 degrees of freedom possible for this rigid body, okay, if I do not consider anything else. And looking at B, okay, by fixing A I am going to look at B, okay. This point here can slide, alright, and this body B can also rotate, okay. There are 2 ways in which we can understand. Let us fix this particular body A, let us take this particular pin as another body, and that pin can have one translation along this direction, okay. So one more degree of freedom, and so I am going to call that as one more degree of freedom. And if I fix this pin as well as this A, the body B can rotate about the pin axis, and therefore it has one more degree of freedom, and therefore this will have 5 degrees of freedom, okay. The only motion here that is arrested between A and B is the translation which is vertical with respect to the slotted line that is shown here, okay. I hope it is clear as far as number of degrees of freedom is concerned. This will help us understand how to write equations of equilibrium, okay. Thank you. Now I have a few challenges for you. So far what we have done should be enough for you to answer these questions. This is a rigid body, let me call this as A. Okay, so let us just look at whether we are correct in this particular problem. We have this body A, okay, and this body can move around or rotate, which means it has 3 degrees of freedom, okay. What we have there is one pin over here like this, okay, and there is one more pin that connects A and C, okay. So you have A, B and C. Let me just connect them. So this is what we have, as you can see A, B and C, okay. We need to find out the degrees of freedom of this system. You can see that you can move around like this, right. Now how do we find it out? We take this body A, we know that it can rotate, it can translate and it can move, which means this body as such we can say has 3 degrees of freedom. Then I fix this to the fixed frame of reference. Just assume that my hand is the fixed frame of reference, left hand is the fixed frame of reference. I am just holding this A completely and do not let it move in any way possible. And if I look at only B, the only possibility for B is to rotate about this particular joint, which means if I focus only on B, B has only 1 degree of freedom, or in other words only one quantity needed to describe the motion of that with respect to A. If I fix this particular body B also with respect to the fixed frame of reference. Body C has only one way in which it can move, or in other words just one single degree of freedom, which is the rotation, can describe what is the motion of this with respect to A and B. So in other words 3 plus 1 plus 1 we have